this lecture we find out the radius of the semicircle. In the drawing we have a semicircle, line segment PA equals to 6 units in its length, and also it is also tangent to the semicircle at points A. Line segment PQ equals to 4 units in its length, and this line segment PS cuts the semicircle at points Q and S. In addition, you know that QS equals to QC. This is angle PAB that is equal to 90 degrees in its size. And this angle SQC equals also to 90 degrees. Again, our mission is to find out the radius of this semicircle. So first of all, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 10. According to rule number 10, if we have the common external point P is an external point in relation to the circle. So if from the common external point P we draw tangent PT to this circle, here tangent PT is tangent to the circle at point T, and also from point P we draw line segment PB that cuts the circle at points A and B. Then in this drawing the following equation is true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. You can actually implement rule number 10 in our drawing. Why? Because in our drawing we have the common external point P. From the common external point P we have tangent PA to the semicircle, and we also have line segment PS that cuts the semicircle at points Q and S. So all the requirements of rule number 10 are met. Therefore we can implement here rule number 10. So according to rule number 10, PA square equals to PQ times PS. Repeat again. According to rule number 10, if we focus at point P, then PA square equals to PQ times PS. PA equals to 6 units in its length, therefore PA square is 6 squared, that is 36, and it is equals to PQ. PQ is 4 times PS. PS equals to PQ plus SQ. That is to say, PS in total equals to PQ, that is 4, plus QS. So PS equals to 4 plus QS. Again. PS equals to 4 plus QS. So in conclusion, we found out that according to rule number 10, 36 equals to 4 times 4 plus QS. Here we will divide this equation by 4. And we will get that 36 over 4 is 9. So 9 equals to 4 plus QS. Here we subtract 4 from this equation. Finally we will get that QS equals to 9 minus 4, that is 5. So QS equals to, this line segment of code QS equals to 4 units, to 5 units in its length. It is given us the question that QS equals to QC, and QS is 5, therefore QC must be also equal to 5 units in its length. In the next step, I will present to you rule number 3, and we will implement rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So in the drawing we have the straight line AB. So if we focus on the upper side of the straight line AB at point Q, here, the sum of the angles must be equal to 180 degrees according to this rule, rule number 3. So which angles we have at the upper side of AB at point Q? We have this angle alpha and angle beta. So in total, alpha plus beta must be equal to 180 degrees according to this rule, rule number 3. We can actually implement rule number 3 in our drawing. Why? Because in our drawing, if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees. Again, in order to complete the sum of the angles in the lower side of the straight line PS at point Q to 180 degrees, the missing angle here must be equal to 90 degrees. In the next step, we'll join points P and C together by a straight line. By joining points P and C, we created here the right triangle PQC. So I will copy the right triangle PQC in a new page, and we will implement the Pythagoras theorem on this right triangle PQC. Here, by PT is a relation for Pythagoras theorem. So actually, this is the right triangle PQC that I covered from the original drawing. Side PQ equals to 4 units according to what is given as the question, and side QC equals to 5 units. Again, by PT is a relation for Pythagoras theorem. So in this right triangle PQC, according to the Pythagoras theorem, PC squared, that is the square of the hypotenuse, equals to PQ squared plus QC squared. So PC squared, that is the square of the hypotenuse, equals to PQ square. PQ is 4, therefore PQ square is 4 squared, that is 16, plus QC square. QC is 5, therefore QC square is 5 squared, that is 25. So in total, PC square equals to 16 plus 25, that is 41. In conclusion, found out that PC square, that is the square of the hypotenuse, it is equals to 41. In the next step, I will copy the right triangle PAC in a new page here, and we will implement the Pythagoras theorem on this right triangle PAC. Again, by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle PAC that I copied from the original drawing. Side PA equals to 6 units according to what is given as the question. And we just write down found out that PC square equals to 41. The square of the hypotenuse equals to 41. So in this right triangle PAC, according to the Pythagoras theorem, PC square equals to PA square plus AC square. PC square is 41, so it says PC square by 41, and it is equals to PA square. PA is 6, therefore PA square is 6 squared, that is 36, plus AC square. In conclusion, found out that according to the Pythagoras theorem, 41 equals to 36 plus AC square. Here we subtract 36 from this equation. Finally, we get that AC square equals to 41 minus 36 is 5. So AC square equals to 5. Here we'll take a root out of this equation, and finally we get that AC equals to the square root of 5 units. So here, this line segment AC equals to the square root of 5 units in its length. So we know that this is a semicircle, and therefore AB must be the diameter of this semicircle. So I'll write it down. AB is the diameter of the semicircle. So if we define the radius of this semicircle as x, the radius of this semicircle equals to x according to our definition. I remind to you that the radius of this semicircle is the radius that we are looking for. So if the radius of this semicircle is x, then the diameter AB must be equal to 2x. So write it down here, AB must be equal to 2x. So what is the length of line segment CB? From the drawing, it is very easy to see that CB equals to AB minus AC. Okay, CB equals to AB minus AC. So I write it down. CB equals to AB minus AC. So CB equals to AB equals to 2x minus AC. You just right now found out that AC equals to the square root of 5 units. So in total, so AC is square root of 5 units. So in total, CB equals to 2x minus square root of 5 units. So you can write down in the original drawing that CB equals to 2x minus square root of 5 units. Okay, so in the next step, we'll complete the semicircle to a circle. So we completed the semicircle to a circle, and we will extend side QC by a straight line until it touches the circle. We will define the touching point of the extended side QC in the circle as point M. In the next step, I will present to you a new rule, and we will implement a new rule in our drawing. So, in the drawing, the new rule is rule number 11. In the drawing, we have two chords that intersect with each other inside the circle. We have chord AB, this is chord AB that intersects with this chord CD at point O. And whenever you have two chords that intersect with each other inside the circle, then the following equation will be true. That AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB, this is chord AB, that intersects with this chord QM at point C. Again, chord AB intersects with chord QM at point C. So I write it down. In our drawing, chord AB intersects with chord QM at point C. The intersection point occurs at point C. So, in our original drawing, we have two chords that intersect with each other. For that reason, we can implement in our original drawing rule number 11. So, according to rule number 11, the following equation will be true. That AC times CB equals to QC times CM. Again, AC times CB will be equal to QC times CM. AC times CB equals to QC times CM. We will define the length of this line segment CB, line segment CM as B. This is again according to rule number 11. In our original drawing, AC times CB equals to QC times CM. So this is equation number 1. AC is equal to 5 units. CB is 2x minus square root of 5 units. And it is equals to QC. QC is 5 times CM. CM is B according to our definition. So actually, according to rule number 11, we found out that square root of 5 times 2x minus square root of 5 equals to 5b. So here we'll divide this equation, equation number 1, by square root of 5. And we'll get that according to equation number 1, 2x minus square root of 5 equals to 5b over square root of 5. Here we will add the square root of 5 to this equation, equation number 1, and we'll get that according to equation number 1, 2x equals to 5b over square root of 5 plus square root of 5. We focus on this side of equation number 1. Here we will multiply square root of 5 by square root of 5, and then we will divide it by square root of 5 in order to have a common factor with this expression. And we get that 2x equals to 5b over square root of 5 plus, again we multiply square root of 5 by square root of 5, and then we divide it by square root of 5, so we change nothing. For that reason, this operation is allowable. So actually found out that according to equation number 1, 2x equals to 5b plus square root of 5 times square root of 5 is 5 over square root of 5. So here we will divide this equation, equation number 1 by 2, and finally we get that according to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. Repeat again, we actually found out that according to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. In the next step, we'll join points S and M together by a straight line, those 2 points. By joining points S and M, we created here peripheral angle SQM. This peripheral angle SQM is equals to 90 degrees in its size. It is a right angle, and we have a rule number 5, so I write it down. Peripheral angle SQM is equals to 90 degrees in its size, and we have rule number 5 that relates to a peripheral angle that is equal to 90 degrees. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. So here we have a circle. Inside this circle we have peripheral angle MAN, and this peripheral angle MAN equals to 90 degrees in its size. According to this rule, rule number 5, peripheral angle MAN must rest on the diameter of the circle. It is very easy to see from the drawing that peripheral angle MAN rests on chord MN, and indeed chord MN is the diameter of the circle. Why? Because chord MN passes for point O, that is the center of the circle. And we know that any chord that passes through the center of the circle must be the diameter of the circle. So in conclusion, we can say that because of the fact that peripheral angle MAN equals to 90 degrees, therefore this peripheral angle must rest on the diameter of the circle, and indeed peripheral angle MAN rests on MN, that is the diameter of the circle. We can actually implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle SQM that is equal to 90 degrees in its size. Therefore, according to rule number 5, this peripheral angle SQM must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle SQM rests on chord SM. And therefore, according to rule number 5, chord SM must be the diameter of the circle. So I write it down. I think again, because of the fact that peripheral angle SQM equals to 90 degrees, according to rule number 5, peripheral angle SQM must rest on the diameter of the circle. That is to say, we know that peripheral angle SQM rests on chord SM, therefore chord SM must be the diameter of the circle. But we know that the radius of the circle equals to x according to our definition, therefore the diameter SM must be equal to 2x. So I write it down. The diameter SM of the circle must be equal to 2x. In the next step, I will copy the right triangle SQM in a new page and we will implement the Pythagoras theorem on this right triangle SQM. So actually, this is the right triangle SQM that I copied from the original drawing. Side SQ equals to 5 units in its length. And side QM, this side QM equals to QC plus CM. That is to say, QM equals to QC, that is 5, plus CM, that is B. So in total, QM equals to 5 plus B. So right here that QM equals to 5 plus B. And the hypotenuse SM of this right triangle SQM equals to 2x. Here, SM equals to 2x. It is the diameter of the circle. So in this right triangle SQM, by PT is the evaluation for Pythagoras theorem. So according to the Pythagoras theorem, this right triangle SQM, SM square, that is the square of the hypotenuse, equals to QS square plus QM square. So SM equals to 2x, therefore SM squared is 2x squared, that is equals to QS squared. QS is 5, therefore QS squared is 5 squared, that is 25, plus QM squared. QM is 5 plus B, therefore QM squared is 5 plus B squared. In conclusion, we found out actually that according to question number 2, x squared equals to 25 plus 5 plus B squared. This is according to equation number 2. Well, according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Now we can substitute x in this equation number 2, by the value of x that we found here in equation number 1. We'll do it now, and we'll get that according to equation number 2, we have 2x squared, so it is 2 times x, and x according to equation number 1 is 5b plus 5 over 2 times square root of 5. So it is 2x squared, so here it will be squared. Again, this expression equals to x, and in equation number 2 we have 2x squared, so it will be 2x squared, that is equals to 25 plus 5 plus b squared. So in this side of equation number 2 we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. After I cancel 2, in this side of equation number 2, we have in the numerator 5b plus 5 squared over, in the denominator we have square root of 5, so it is over square root of 5 squares. Square root of 5 squared is 5. So in total, in this side of equation number 2, we left only with 5b plus 5 squared over 5. That is equals to, in the other side of equation number 2, we have 25 plus 5 plus b squared. 5 plus b squared equals to 5 squared, that is 25, plus b squared plus 2 times 5b is 10b. We'll open the brackets on this side of equation number 2, and we get that according to equation number 2 we have 5b plus 5 squared is 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, and 10b times 5 is 50b, all divided by 5, and it is equals to 25 plus 25 is 50, plus b squared plus 10b. So actually found out that according to equation number 2, 25b squared over 5 is 5b squared, plus 25 over 5 is 5, plus 50b over 5 is 10b, and it is equal to, on the other side of equation number 2 we have 50 plus b squared plus 10b. So here we have 10b on both sides of the equation, so 10b will get cancelled. After we cancel 10b, in this side of equation number 2 we left only with 5b squared plus 5. And it is equal, on the other side of equation number, in this equation number 2 of the cancel 10b, we left only with 50 plus b squared. So according to equation number 2, 5b squared plus 5 equals to 50 plus b squared. Here we'll subtract b squared from this equation number 2. And finally, we'll get that according to equation number 2, 5b squared minus b squared is 4b squared, plus 5, that is equals to 50. Repeat again, according to equation number 2, we found out that 4b squared plus 5 equals to 50. Here we subtract 5 from this equation number 2, and finally we get that according to equation number 2, 4 b squared equals to 50 minus 5 is 45. So 4b squared equals to 45. Here we'll divide this equation number 2 by 4. And finally we'll get that b squared equals to 45 over 4. So b squared equals to 45. 45 is 9 times 5, so we substitute 45 by 9 times 5 over 4. Here we take a root out of this equation number 2, and finally we will get that p equals to the square root of 9 times 5 over 4. So, according to equation number 2, we found out that b equals to the square root of 9 is 3 over the square root of 5 is 2. Inside the root we left only be 5. So in conclusion, we found out that according to equation number 2, b equals to 3 times square root of 5 over 2. This is according to equation number 2. While according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. So, according to equation number 2, b equals to 3 times square root of 5 over 2. Now we can put the value of b that we found in this equation number 2 here in equation number 1. So we do it now, and you get that x equals to 5b, and b according to equation number 2 is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. Okay? Actually, we put the value of b in equation number 2 here in we put the value of b from equation number 2 here in equation number 1. So actually found out that according to equation number 1, x equals to 5 times 3 is 15. So in conclusion, in total this expression equals to 15 times square root of 5 over 2 plus 5 all divided by 2 times square root of 5. So here we multiply 5 by 2 and then we will divide it by 2 in order to become factor with this expression. And we get that according to equation number 1, x equals to 15 times square root of 5 over 2. And there it is plus, we will multiply 5 by 2. 5 times 2 is 10, and then we divide it by 2, so we change nothing. All divided by 2 times square root of 5. In the next step, we will remove 2 times square root of 5 to the denominator here. And we get that according to equation number 1, x equals to 15 times square root of 5 plus 10 over 2 over 2 times square root of 5. I repeat again. Found out that according to equation number 1, x equals to 15 times square root of 5 plus 10 over 2 times square root of 5. So in the denominator we have in total 2 times square root of 5. 2 times 2 is 4, so in total in the denominator we have 4 times square root of 5. So I write it down. According to equation number 1, x equals to 15 times square root of 5 plus 10 over 4 times square root of 5. So according to equation number 1, x equals to 15 times square root of 5 plus 10. So here we will substitute 10 by square root of 5 times square root of 5 times 2. 10 equals to square root of 5 times square root of 5 times 2, all divided by 4 times square root of 5. So according to equation number 1, x equals to, here we take square root of 5 as a common factor from those two expressions in the numerator. So square root of 5 is taken out as a common factor from those two expressions. So what is left from square root of 5 times 15 after we took away square root of 5 as a common factor? What is left? It is actually 15 plus what is left from square root of 5 times square root of 5 times 2 after we took from it square root of 5 as a common factor. What is left? It is actually square root of 5 times 2, all divided by 4 times square root of 5. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally we found out that x equals to 15 plus 2 times square root of 5 over 4. In terms of numbers, this expression equals to 4.8680 units. And that is the answer to the question. I repeat again, the radius x of this semicircle equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, the radius x of this semicircle equals to 4.8080. Again, the radius x equals to 4.8680 units. I repeat again, the radius x equals to 4.8680 units. Okay, so in the next step, I'll summarize the lecture. In this lecture, we found out the radius of this semicircle. So, in the drawing, we have a semicircle. PA is tangent to this semicircle at point A. The length of line segment PA is 6 units. Line segment PQ equals to 4 units in its length. And also, line segment PS cuts the semicircle at points Q and S. In addition, we know that QS equals to QC, and this is angle PAB is equal to 90 degrees in size, and this angle SQC also equals to 90 degrees in size. Again, our mission is to find out the radius of this semicircle. Okay, so first of all, I presented to you a new rule, and we implemented the new rule in our drawing. The new rule is rule number 10. According to rule number 10, if we have this circle and we have the common start point, point P, and from the common start point, point P, we draw tangent PT, that is tangent to the circle at point T, And also from the same common standpoint point P, we draw line segment PB that cuts the circle at points A and B. So in this drawing, the following equation will be true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. You can actually implement rule number 10 in our drawing. Why? Because in our drawing, we have the common standpoint point P. From the common standpoint point P, we have tangent PA that is tangent to the semicircle point A. And also from the same common standpoint point P, we have line segment PS that cuts the semicircle points Q and S. So all the requirements of rule number 10 are met. Therefore, we can implement here rule number 10. According to rule number 10, we get that PA square equals to PQ times PS. Again, according to rule number 10, PA square equals to PQ times PS. PA is 6, therefore PA square is 6 squared, that is 36. And it is equals to PQ, that is 4, times PS. What is the length of PS? PS equals to PQ plus QS. That is to say, PS equals to PQ, that is 4, plus QS. So in total, PS equals to 4 plus QS. So here we substitute PS by 4 plus QS. So in conclusion, found out that according to rule number 10, 36 equals to 4 times 4 plus QS. Here we divided this equation by 4. And finally found out that 36 over 4 is 9. So 9 equals to 4 plus QS. Here we subtracted 4 from this equation. And finally found out that QS equals to 9 minus 4, that is 5. Yeah. This line segment or QS or code QS equals to 5 units in itself. But because of the fact that it is given us the equation that QS equals to QC and QS equals to 5, therefore QC must be also equal to 5 units in itself. Then I presented to you rule number 3, implemented rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. In the drawing, we have the straight line AB. If you focus on the upper side of the straight line AB at point Q, here, the sum of the angles must be equal to 180 degrees according to this rule, rule number 3. So which angles we have at the upper side of AB at point Q? We have this angle that is alpha, and the other angle that is beta. So in total, alpha plus beta must be equal to 180 degrees according to this rule, rule number 3. Actually, we can implement rule number 3 in our drawing. Why? Because in our drawing, if you focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles in the lower side of PS at point Q to 180 degrees, the missing angle here must be equal to 90 degrees. Then we join points P and C together by a straight line. In this way, we created the right triangle PQC. So I copied the right triangle PQC in a new page, and we implemented the Pythagoras theorem in this right triangle PQC. So actually, this is the right triangle PQC. That I copied from the original drawing. Side P equals to 4 units in its length, side QC equals to 5 units in its length, according to what we already found out, that PQ equals to 4 units according to what is given us the question. Here by PT is the equation for Pythagoras theorem. So according to the Pythagoras theorem, in this right triangle PQC, PC square equals to PQ square plus QC square. So PC square, that is the square of the hypotenuse, equals to PQ square. PQ is 4, therefore PQ square is 4 square, that is 16, plus QC square. QC is 5, therefore QC square is 5 square, that is 25. So in total, PC square equals to 16 plus 25, that is 41. Okay, here PC square, the square of the hypotenuse, equals to 41. Then I copied the right triangle PAC here, and we implemented the Pythagoras theorem in this right triangle PAC. Side PA equals to 6 units according to what is given in the question. This is the right triangle PAC that is covered to the original domain. We just right now found out that PC squared equals to 41. So in this right triangle PAC, by PT is a version for Pythagoras theorem, PC squared equals to PA squared plus AC squared. So PC squared equals to PA squared. PA is 6, therefore PA squared is 6 squared, that is 36, plus AC squared. So in conclusion, found out that 41 equals to 36 plus AC squared. Here we substitute 36 for this equation. And finally found out that AC squared equals to 41 minus 36 is 5. So AC squared equals to 5. We took out of this equation and finally found out that AC equals to the square root of 5 units. Here, this line segment AC equals to the square root of 5 units in its length. Here, we know that this is a semicircle, and for that reason, AB must be the diameter of the semicircle. AB is the diameter of the circle, so if we define the radius of this semicircle as x, then the diameter AB must be equal to 2x. So what is the length of line segment CB? From the domain, it is very easy to see that CB equals to AB minus AC. So CB equals to AB, repeat again, CB equals to AB minus AC. So CB equals to AB, that is 2x, minus AC, that is square root of 5. So in total, CB equals to 2x minus square root of 5. Here, CB equals to 2x minus square root of 5. Then we completed the semicircle to a circle, and we extended side QC by side line until it touches the circle. We define the touching point of the extended side QC in the circle as M. Then I presented to you a new rule, and we implemented the new rule in our domain. The new rule is rule number 11. So in the domain we have a circle. Inside the circle we have chord AB that intersects with chord CD at point O. Again, chord AB intersects with chord CD at point O. So whenever you have two chords that intersect with each other inside the circle, then the following equation will be true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. We actually can implement rule number 11 in our domain, because in our domain we have also two chords that intersect with each other inside this circle. Here we have chord AB that intersects with chord QM at point C. Again, chord AB intersects with chord QM at point C. Repeat again. Now our original domain, chord AB intersects with chord QM at point C. So because of the fact that in our original domain we have two chords that intersect with each other, we can implement a rule number 11. According to rule number 11, AC times CB equals to QC times CM. Again, AC times CB equals to QC times CM. Repeat again, according to rule number 11, AC times CB equals to QC times CM. AC is square root of 5, CB is 2x minus square root of 5, QC is 5, and CM is B according to our definition. If CM is B. So this is equation number 1. Here we divided this equation number 1 by square root of 5, and found out that according to equation number 1, 2x minus square root of 5 equals to 5b over square root of 5. Here we added square root of 5 to this equation number 1, and found out that 2x equals to 5b over square root of 5 plus square root of 5. Here we multiplied square root of 5 by square root of 5, and then we divided by square root of 5 in order to overcome factor with this expression. And found out actually that 2x equals to 5b, and then we multiplied square root of 5 by square root of 5, and then we divided by square root of 5, so we changed nothing. So in conclusion, found out that 2x equals to 5b plus square root of 5 times square root of 5 or square root of 5. So 2x equals to 5b plus square root of 5 times square root of 5 is 5 over square root of 5. Here we divided this equation number 1 by 2, and finally we found out that according to equation number 1, x equals to 5b plus 5 over 2 times square root of 5. This is equation number 1. And here we joined points S and M together by straight line. In this way we created peripheral angle SQM. Peripheral angle SQM equals to 90 degrees in its size. And we have rule number 5 that relates to a peripheral angle that is equal to 90 degrees. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. In the drawing we have a circle. Inside the circle we have peripheral angle MAN. This peripheral angle MAN equals to 90 degrees in size. Therefore, according to this rule number 5, this peripheral angle MAN must rest on the diameter of the circle. From the drawing itself, it is very easy to see that peripheral angle MAN rests on chord MN. And it is very easy to see that MN is indeed the diameter of the circle. Why? Because of the fact that chord MN passes through point O, that is the center of the circle. We know that any chord that passes through the center of the circle must be the diameter of the circle. So you can say in rule number 5 that because of the fact that peripheral angle MN equals to 90 degrees, therefore it rests on MN, that is the diameter of the circle. So any peripheral angle is equal to 90 degrees in size must rest on the diameter of the circle. So we can actually implement rule number 5 in our drawing, because in our drawing we have peripheral angle MQS or SQM is equal to 90 degrees. Therefore, this peripheral angle, according to rule number 5, is, we have peripheral angle MQS that is equal to 90 degrees. Therefore, according to rule number 5, this peripheral angle SQM must rest on the diameter of the circle. From the drawing, it is very easy to see that peripheral angle SQM rests on chord SM, and therefore, according to rule number 5, chord SM must be the diameter of the circle. Okay, so we can write here that according to rule number 5, SM must be the diameter of the circle. According to our definition, the radius of the circle is x, therefore the diameter SM must be equal to 2x. So here, the diameter SM equals to 2x. Then I copied the right triangle SQM in a new page and implemented the Pythagoras theorem in this right triangle SQM. This is the right triangle SQM that I copied from the original drawing. Side SQ equals to 5 units, and QM equals to 5 plus B. Put again, SQ equals to 5 and QM equals to 5 plus B, and just right now found out that SM equals to 2x. It is the diameter of the circle. So in this right triangle SQM, SM square equals to QS square plus QM square. Again, SM square equals to QS square plus QM square. So SM is 2x, therefore SM square is 2x square. QS is 5, therefore QS square is 25. Plus QM square. QM is 5 plus B, therefore QM square is 5 plus B square. So in total, we found out that according to equation number 2, 2x squared equals to 25 plus 5b plus b squared. This is according to equation number 2. While according to equation number 1, we already found out that x equals to 5b plus 5 over 2 times square root of 5. Now we can substitute x in this equation number 2 by the value that we found for x in this equation number 1. We did it and we found out, actually, here in equation number 2 we have 2x squared. So it is 2, and x according to equation number 1 is 5b plus 5 over 2 times root of 5 squared. So this expression in total equals to 2x squared, and it is equals to 25 plus 5 plus b squared. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. After we cancel 2, in the numerator we left only with 5b plus 5 squared over square root of 5 squared. Square root of 5 squared is 5. So in total this expression equals to 5b plus 5 squared over 5, and it is equals to 25 plus 5 plus b squared. 5 plus b squared equals to 5 squared, that is 25, plus b squared, plus 2 times 5b, that is 10b. Okay, so here we have 25 plus 25 is 50. So in this side of the equation we have 50 plus b squared plus 10b. We open the brackets. On this side of the equation number 2, 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, and 10b times 5 is 50b, all divided by 5. And it is equal to 50 plus b squared plus 10b. So here we have 25b squared over 5 is 5b squared, 25 over 5 is 5, and 50b over 5 is 10b. That is equal to 50 plus b squared plus 10b. Here we have 10b on both sides of the equation, so 10b will get cancelled. After cancelling 10b, in this side of the equation we left only with 5b squared plus 5. That is equals to, in the other side of the equation, we left with 50 plus b squared. Here we subtracted b squared from this equation, equation number 2, and finally found out that 5b squared minus b squared is 4b squared. So in this side of the equation we have 4b squared plus 5, that is equal to 50. Check again. We found out already that 4b squared plus 5 equals to 50. Here we subtracted 5 from this equation, equation number 2, and finally found out that 4b squared equals to 50 minus 5 is 45. So 4b squared equals to 45 according to equation number 2. We divided this equation, equation number 2 by 4, and finally we found out that b squared equals to 45 over 4. Okay, so b squared equals to 45. 45 is 9 times 5 over 4. Then we took out of this equation, equation number 2, and finally we found out that b equals to the square root of 9 times 5 over 4. So b equals to the square root of 9, that is 3, over square root of 4, that is 2. Inside the root, we left only with 5. So according to equation number 2, we found out actually that b equals to 3 times square root of 5 over 2. So we have the value of b in terms of numbers. This is according to equation number 2, while according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. So now we can put the value of b that we found in equation number 2 inside this equation, inside b in this equation, equation number 1. We did it and we found out actually that x equals to 5b, and b is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. Here we have 5 times 3 is 15, so in total this expression equals to 15 times square root of 5 over 2 plus 5 over 2 times square root of 5. So x equals to 15 times square root of 5. Here we multiplied 5 by 2 and then we divided by 2 in order to account factor with this expression. So 5 times 2 is 2, divided by 2, all divided by 2 times square root of 5. Then we moved 2 times square root of 5 to the denominator here. And finally, we found out actually that x equals to 15 times square root of 5 plus 10 over 2 times 2 times square root of 5. 2 times 2 is 4, so in total in the denominator we have 4 times square root of 5. Therefore this expression equals to x equals to 15 times square root of 5 plus 10 over 4 times square root of 5. So x equals to 15 times square root of 5 plus 10. 10 is square root of 5 times square root of 5 times 2, all divided by 4 times square root of 5. Then we took square root of 5 out as a common factor out of those two expressions in the numerator. So square root of 5 is taken out as a common factor from those two expressions. So what is left from 15 times square root of 5 after we took from it square root of 5 is a second factor. What is left it is actually 15. And what is left from square root of 5 times square root of 5 times 2 after we took from it square root of 5 as a second factor, what is left? It is actually 15 square root of 5 times 2. Okay. All divided by 4 times square root of 5. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally we found out that x, that is the radius of this semicircle, the radius that we are looking for, x equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, x, the radius of this semicircle, equals to 4.8680 units. So repeat again, the radius x of this semicircle equals to either 15 plus 2 times square root of 5 over 4 units, or in terms of numbers, the radius x of this semicircle equals to 4.8680 units. Okay, thank you very much.